Number 1 says solve each system by graphing. So these are both set up in y equals, which means we can go straight to our y-intercept, which on the first equation is -3. And then we'll use the number in front of x, which would be a 1, to do our slope. So since it's a positive 1, that's up 1 and right 1. And the more points we make, since we're going to try to find where these two lines intersect, the easier it will be, because they're going to most likely intersect at one of these nice points that I've drawn. That's our first line. Our second line is equally easy to graph because we have our y-intercept again, which is 4, and then -6/1 is our slope, which means to go down 6 and right 1. So even without drawing the line, we can see that point where we are crossing. Although we still have to draw the line because that's our work that we're showing. So our answer to this is 1, -2, because that's the point right here where the two lines cross. On number 2, we're going to do something similar, but this time we have inequalities, and so we solve these for y like we normally would, and then remember that if it's less than, we shade below, if it's greater than, we shade above. So to solve this first one for y, I first need to move my x over by subtracting it, since it was a positive x. So that gives me 2y is less than or equal to -x minus 4. And then I can divide both sides by 2. And I get y is less than or equal to -x/2 is like -1/2 x. And then -4/2 is -2. So if I graph that line, that's -2 for my y-intercept, and down 1, right 2, or up 1, left 2 for my slope. I'm going to connect those dots and draw my line. It is a solid line because it's equal to as well as less than. And then below this line is this direction, okay? Because remember, if you put your pin somewhere on it and then draw down, that's the side that's below. Now the second one on here is easier to solve because all we have to do is subtract the 3x over to the right side. And so that means our y-intercept is 3, because that's the number that's by itself and doesn't have an x. And then our slope is -3/1, so that's down 3, right 1. And so the lines do cross, although we don't really care as much about where they cross because we're wanting to shade this. Since it's less than on this one, we're going to shade below this line as well, which is this direction. And so if you think about below the red line, which is here, and below the green line, which is here, what we need to color is where those two places overlap, which is here. Okay, because we want it to be below the red line, but also below the green line. So this part I have shaded in yellow, which that color may have been a poor choice on my part, but there you go. Now parabolas can open left, right, up, or down, and to tell which way it's opening, you look at what letter it's solved for, and then you look in front of your parentheses at whether that's a positive or a negative number. So first off, if it's y equals, it's up or down, and since it's a negative in front, that means it opens down. So this one's y equals, but it's positive in front, so that means it opens up. X equals is left or right, and a positive in the x direction is right. Negative, whenever it's x equals, means we're going left. Now, when we're finding the vertex, when I look inside my parentheses and I grab this number, because it's inside parentheses, I have to change the sign. But the other thing I care about is that this -1 is next to x, so this is telling me my x value. The outside number is telling me my y value. But when we look at 5, this number, which is telling us that -7 is important, is next to y. So you have to remember that that's telling me my y value. The outside number is telling me my x value. Okay, so when it's y equals, this is my x and this is my y. So 2, -10. So remember, we changed the sign of what's inside but not what's outside. So here, because it's x equals, this is a 6 for our y value and -10 for our x value. Okay, so if you can remember, basically for parabolas, everything is backwards whenever you do x equals instead of y equals. Let's use the information provided to us to write the vertex form equation of each circle. So I want to remind you what that equation looks like. Just so we're on the same page. So H and K are our center. R is our radius. Now we don't know our radius, we know our diameter. And so because the diameter is all the way across and the radius is just halfway across, we need to do 14 divided by 2, which is 7. So that's R. Now I know all the letters I need, so I would write this as x minus 10 squared plus y plus 8 squared equals 7 squared, which is 49. Here on 8, we're going to use the same formula, but we have to get the information from the graph. This middle point is our center, and it's at -1, -3. And then we have a radius, and we need to be careful because if you look at your scale on this graph, to go from here to here is going from -3 to -2. So this is a radius of 1, and if you're just counting squares, you would probably say it's 2, and that's wrong. So I'm going to write the equation over here, x plus 1 squared plus y plus 3 squared equals our radius squared, which is 1 squared, which is 1. Number 9, now we've got an ellipse, and so in general our ellipses will end up looking like this equation on 10. So if you do forget what the vertex form of an equation looks like when you're taking the test, look around and see if you can see hints of it other places. So for this we need our center, which is 3, 2. That's going to be h and k that go up on the top of our fractions. And then we need to know how much am I going left and right, which I'm going left and right 3. How much am I going up and down, which is 5. Those are the numbers that we're going to square and put on the bottom of our fractions. So this is going to be x minus 3 squared over how much we went left and right, which was 3 squared, plus y minus 2 squared over how much I went up and down. So 5 squared is 25, and then it equals 1. Now, on 10, it asks us to identify the center. Remember, that's what's inside of our parentheses, and because it's inside our parentheses, we change the sign. So this is -5, -3. To get the major and minor axis, we're going to have to square root both of these numbers. So 9 and 12, but that tells us only one direction, like 9 is how much we're going right or left, so total I would have to go 18, and since that's smaller than the other one, it's my minor axis. Whenever I square root 144 and get 12, again, that's only my up or my down, so together up and down would make 24. And that's the bigger number, and so that's why it's major. Major is always the bigger one. Okay, so this says to write the vertex form equation of each hyperbola. The vertex form for hyperbolas looks just like the ellipse equation, like from number 10, except in the middle there's a minus sign, which means that the order that we put it in matters. For instance, we have our hyperbola on top and bottom here, so that means that y has to come first and x has to come second in our equation. It might help you to draw the box here a little bit more pronouncedly, or whatever. If you have problems seeing where the box is, remember, like, it has to touch the box where my hyperbola is, but as far as left and right here goes, my lines have to go through the corners of my box. So the center of our box is at 1, 0. I said y has to go first, so we could put y minus 0 squared, or we can just put y squared. That's going to be over how much I'm going up and down, which is 5 squared. So when we put these numbers on the bottom of our fractions, we always square them. Then minus, and then for x, it's x minus 1 squared over how much we're going left and right, which would be 2. That has to be squared. So y squared over 25 minus x minus 1 squared over 4 equals 1 is number 11. Number 12, well, you may notice the big difference here is that it's on the left and right side instead of the top and the bottom. So this time x will go first. My center point is 1, -3. Again, it might help you to trace out the box, but we're going left and right 3 and up and down 1. X needs to go first because it's on the left and right side, so x minus 1 squared over, I'm going left and right 3. 3 squared is 9, minus y plus 3 squared over 1 squared, which is 1, equals 1. Now we could rewrite this or just use our handy dandy eraser and just make this not be a fraction anymore, because we don't need that 1 on bottom. You can leave it on there if you want to, but this would be our best answer for 12. 13, identify the center and radius of each circle, then sketch the graph. So the center comes from what's next to x and y, so this -2 switches to a +2. There's not anything right next to y, and so that makes it a 0. So our center is 2, 0. Our radius, remember, we have to square root the number on the right, and so that gives us 2. So I'm going to go to 2, 0. It's really easy, by the way, to mess up where you put that and put it up here instead, but remember, we're going right to and not up or down, which is a point over here. And we're going to go 2 in each direction and then draw our best possible circle that hopefully doesn't look too much like a diamond, because circles and diamonds aren't the same thing. Alright, now we're going to sketch an ellipse. So our center, we get the same way we did with the circle. On top here, next to x squared, there's not anything, so that's 0. Next to y is -3 once we change the sign. I square root these numbers, and so I get 7 for x, and that's the bigger number, so that's 14 for my major axis. I get 3 for y, which gives me 6 for my minor axis. So go to 0, -3, and we're going to go left and right 7, which is how we get our total of 14, up and down 3, which is how we're getting our total of 6. And here we go. That's an okay looking ellipse. Graph the hyperbola. It says state the center, major axis, and minor axis, and more likely than that, it would probably tell us to find the vertices. Remember, the vertices are where our hyperbola touches our box. So the center of this one is 4, 1. This would be like over 1 because it doesn't have a fraction, and so we'll square root both of these numbers to figure out our left and right and our up and down. X is first, which means our graph will be on the left and right side. So I'm going to graph 4, 1. I'm going to go left and right 1, up and down 4, and draw my box. That's step 1. Then I'm going to draw my lines that go through diagonally on my box. It doesn't have to be perfect, it just has to get the point across. Now, I said X was first, and so that means we're going to draw from the center of our box on the left side and make it U-shaped headed towards our dotted lines. And on the right side, same deal. And so that's our hyperbola. Now we can tell what our vertices are. Now that we have it graphed, I think it's way easier once it's graphed to tell. This would be at 3, 1. And then this one would be at 5, 1. Now let's do the same thing for 16. So this time our center, we have to pay attention. Our X value is 1 and our Y value is 3 because they're switched around. Okay, this is telling me my X value, this is telling me my Y value. I'm going to have to square root these numbers on bottom, get 2 and 4. So my center is at 1, 3. I'm going to go left and right 4 because that's what's underneath X. And then up and down 2 because that's what's underneath Y. And I'm going to draw myself a box. Okay, now my hyperbola is on the top and bottom of my box. It touches in the middle and then would go up. Now both of these happen to be on the wider side of our box, but that wouldn't necessarily have to happen. It just worked out this way. Like if X had been first on this, but otherwise we had the same numbers, I would have had a skinnier hyperbola on either side, on the left and right. But anyway, our vertices are the top here, which is 1, 5, and the bottom, which is 1, 1. Identify the vertex of the parabola, then sketch the graph. So our vertex comes from this number inside, which is -6, and our number outside, which is -4. Remember that this is telling us our X value because it's in the parentheses with X. So -6, -4 is the most important point of our parabola. We know because it's Y equals and it's positive that it's going to open up, but to get a decent idea of what our graph looks like, we would want to look at a table of values or make our own table of values. And if we're making our own, then what's important is that -6, -4 is like our middle point that we want, and we're going to have to find points on either side of it. And so we can either graph it and look at our table of values on our calculator, or we could plug -8 in for X and figure out what that is, which if you do that, you get 4, which means that down here this should be 4 because we are going to have symmetry around our vertex. If I plug in -7, I get -2, so this will be -2. And so that means I have plenty of points to graph to get my U-shaped parabola that opens up. And if it was x equals instead of y equals, you would still plug it into y equals, but then if you look at the table of values, you would want to take those points and write them backwards. So like if we had a point in our table of values that was like 1, 3, it would really be 3, 1, because by plugging it into y equals, even though it was x equals, we're switching the x's and the y's. So just in case that happens, that's how we would do that. Classify each conic section as either parabola, circle, ellipse, or hyperbola. Write the equation in vertex form. So the way we know that what this is we look at x squared plus y squared. Since there's not numbers in front of either of those, and since we have both variables squared, this would be a circle. So to write it in vertex form, we complete the square. So I start that by putting my x's next to each other, my y's next to each other, and then I'm going to move this +8 to the other side, which makes it a -8. To figure out what goes in my blank, I use Professor Hoffensquare's rules, which means I take the 4, I half it, and then square it. So that's +4. But I can't just do it to one side, I have to do it to the other side as well. Same thing with the -6. I'm going to divide by 2 and then square it. So that gives me 9 and 9. So now I'm ready to factor. What multiplies to get 4 and adds to get 4 is 2. And what multiplies to get 9 and adds to get -6 is y minus 3. Then I add these numbers on my right side, and I get 5. If I was going to graph this, this would be unpleasant because that would be a radius of square root of 5, but we don't have to graph it, so we're good. If you have problems remembering what the numbers in the parentheses are here at the end, it's always going to end up being the number you got after you halved and before you squared. So that's how one way to know that it was 2 and -3. Now 19, I have an x squared and a y squared, which means it's not a parabola. I have them both as being positive, so it can't be a hyperbola. And because there's different numbers in front of x squared and y squared, the 4 and the 9, that means that this is an ellipse. Because different numbers means that I'm not going to have a constant radius. I'm going to have almost like 2 different radii. So I'm going to write down that this is an ellipse. I'm going to group my x's together. And while I'm at it, I'm going to take a 4 out of both of them because I can't complete the square if I have a number in front like that. And so then I'm going to do the same thing with my y's. And this time I need to take a 9 out, which gives me y squared minus 4y. And then finally this -104, I'm just going to move over to the other side, which makes it a +104. Now we're ready to Hoffensquare. And so I half -2, which gives me -1. I square it, and that gives me +1. So I put +1 in the parentheses. But to keep my equation balanced, I have to pretend like I would distribute this, which is 4 times 1, which is 4. And that's what I add over to the right side. Okay, I didn't really add 1 to this side. I really added 4 times 1. But what I want in parentheses so I can factor is that 1. So here, I'm going to half and square -4. And that gives me +4. And again, I have to keep my equation balanced, so I need to think of this as 9 times 4, which is 36. And that's what I add to the right side. Believe it or not, we're almost done with the problem now. The 4 still hangs out outside. Let's factor x squared minus 2x plus 1, which factors into x minus 1 squared. then y squared minus 4y plus 4 factors into y minus 2 squared, and then it equals 104 plus 4 plus 36, which is 144. Now, we're almost to standard form, and if you get stuck at some point when you're doing this, on the test, you would want to look back and see what standard form looks like on a problem where it's given to us. I need a 1 on this side, so I'm going to divide everything by 144. So this is also going to get me the fractions that I want. That would tell me my left and right and up and down. Now, unfortunately, I don't have a calculator next to me, so I'm going to have to try to do this in my head. 144 divided by 4 would be 36. And then 144 divided by 9 would be 16. If you're super impressed by my mental math skills, I actually did this earlier today, so it was kind of fresh in my mind. Although you can still be impressed if you want to be. This is my answer. This is the ellipse in vertex form. 2 more. So when you see x squared and y squared and a minus sign either in front of y squared or it could have been in front of x squared, that makes this a hyperbola. Okay, so that means that I'm going to do very similarly to what I did with my ellipse. In fact, it's almost identical. I'm going to group my x's together, and I need to take out a 9 because that's what's in front of x squared. So I need to take that 9 out of 36. Remember, whenever I say take out, when I'm talking about factoring, that I divide 36 by 9 because we're doing the opposite of distributing. And so that means that I need to think about what would I put there so that if I distributed, I would get what I started with. And so that gives us 4x. Now, this minus y squared, I have to take the negative 1 out. I can't just leave it alone. So if I take a negative out of that, I also have to take a negative out of that. Well, how do you take a negative out of a positive? You change it and make it negative, because 2 negatives make a positive in math and English, but not in real life. 26 moves to the other side, so that's negative 26. Now I need to fill in my blanks by halving and squaring. So that's 4 divided by 2, which is 2, squared is 4. But I really put 9 times 4, which is 36. So that's what I put on this side to keep me balanced. Here I half and square negative 2, which gives me a positive 1. If I think about distributing, that gives me a minus 1 to put on the other side. So this is 9. I factor into x plus 2 squared minus 1, and I factor into y minus 1 squared, and then I have negative 26 plus 36 plus 1. I mean minus 1, sorry, which is 9. And then I divide everything by 9 to finish. 9 over 9 completely cancels, so we can just write that as x plus 2 squared. The 1 over the 9 doesn't simplify, but we don't need to write the 1 in front. So that'd be y minus 1 squared over 9, and it equals 1, so this is our answer. Now, this leaves us with a parabola, which the parabola to me is the easiest to spot because there's only one letter that's squared. So there's no x squared in this, which means it's a parabola. And so if I was actually doing these 4 problems on a test, I personally would go through and figure out which one the parabola is, because it's the one with only one squared term. Then I'd look for a hyperbola, because it's the one with the minus in between x squared and y squared, or in front of x squared or whatever. And then I would look at my last 2 choices and say, well, the circle has the same number in front of x squared and y squared, usually not a number at all. The ellipse, though, has to have different numbers in front of each. So to get standard form for a parabola, you solve for the variable that you can solve for. Like I can't solve for y because I've got too many y's here. So I'm going to solve for x to start off with. So that means I'm going to subtract y squared, add 12y, and minus 52 to the right side. Because remember, you don't just move them and leave them the same. You have to subtract them or add them over. Now, this 4, we would be best, the best idea would be to leave it there. We could divide everything by 4, but we'll end up with a fraction, and nobody wants to do that. So I need to take the negative out of these, the negative that's in front of y squared, which gives me y squared minus 12y. Put a blank. I don't take it out of the last number because the last number is not involved in my completing the square. I only use the y's for that. So I figure out what to put in this blank. I half negative 12, which is negative 6, and then I square it, so I get plus 36. Now, I didn't really add 36, I really subtracted 36, because if I think about distributing that negative, that would be a negative 36. Now, I put a negative 36 on the right, so I need to put minus 36 on the left. So I get 4x minus 36 equals negative 1. I can go ahead and factor this into y minus 6 squared. And the only thing that's wrong with it now is that I don't have x by itself, so I would finish by adding 36, which is 4x equals negative 1 times y minus 6 squared. Negative 52 plus 36 is, I think, negative 16. Then we have to divide everything by 4. And when we do that, this whole thing right here is one term. So that gets divided by 4. That gets divided by 4. So I get x equals, I don't want to divide the 4 into the parentheses because that doesn't really work out the way you would think it would because of the minus sign and because of the squared. So instead I'm just going to write this as negative 1/4 in front. And then negative 16 over 4 is negative 4. That would be my answer. Now I will admit that this problem was a little bit more difficult than I intended, all because of that 4 in front of x. If it had not been a number in front of x, then that last step wouldn't have had to happen, and so that's the part where I think it gets extra tricky. So you would not expect to see that on a test. You'd expect to see one of our easier parabola completing the square situations from when we did this in class. But that's it. Have fun.